In this lesson, we're going to graph parabolas by finding ordered pair solutions, completing the square, and the vertex formula. We'll begin by graphing quadratic functions by finding ordered pair solutions. So here we're given an equation f of x equals x squared minus 4x minus 2 and asked to graph this function. So what we're going to do is just create a little chart just to organize our values, and we're going to plug in values for x to see what we get out for y, and then we're going to go ahead and graph them. So let me just randomly pick some numbers that we're going to plug in here for x. Now let's go ahead and plug these values in so we can see what our output or our y value would be, and then we're going to plot those ordered pairs until we're able to see the sketch of our graph. So starting with plugging in a -1 for x, so we're going to remove the x, replace it with -1. When we do the math here, we see -1 squared, that's going to be 1. Combining a -4 times -1, that's going to be a +4. So I'm going to have these three numbers of a 1, a 4, and a -2. 1 plus 4 is 5, and 5 take away 2 is 3. So when we plug in a -1, what we get out is a 3. So we have one ordered pair. Let's move on. This time let's plug in a 0 for x. When we do so, it's going to look like so. We can readily see that our output is going to be a -2, so that ordered pair then is 0, -2. And now let's plug in a 1 in x's place. So here we have 1 squared, which equals 1. We're going to have -4 as our middle number. When we combine those numbers, a 1 with a -4 is going to be a -3. -3 added with -2 is going to be -5. So when we plug in a 1, what we get out is a -5. Next, we're going to plug in a 2. Once we plug in a 2 and do the math, 2 squared is 4. The middle number is going to be a -8. When we combine those three numbers, we get -6 because a +4 and a -8 is going to give you a -4. -4 combined with a -2 will give you the -6. So we have that ordered pair. Moving on, letting x be 3. 3 squared is 9. The middle term we're going to have is a -12. Combining those three numbers together will give us a -5 because a +9 and a -12 is going to give us a -3. -3 combined with a -2 is going to give us -5. Next, we're going to plug in a 4 in x's place. 4 squared is 16. In the middle term, we have -16, so 16 take away 16 is 0. So that leaves us with just -2. So the ordered pair then is 4, -2. Lastly, let's plug in a 5 in x's place. 5 squared is 25. In the middle, we're going to have -20. When we combine those numbers together, 25 take away 20 is 5, and 5 take away 2 does give us 3. And now that we have our ordered pairs, let's go ahead and plot them on the rectangular coordinate system so that we can see the sketch of our graph. So the first point is going to be over -1 and up 3. The other one is 0 and down 2. Over 1 and down 5. Over 2 and down 6. Over 3 and down 5. Notice that our graph is taking a turn. That's that curve. So we know that our vertex here is located at 2, -6. Once you find out what your vertex is, the other points, you can even find those symmetrically because our axis of symmetry is at 2, which means that if this point is 1, 2 to the left, there's also going to be a point 1, 2 to the right. The same for the other point that's up. We have 1, 2, 3 to the left. So that means it would make sense that it's going to be 1, 2, 3 to the right on the other side. But we can continue to plot the points we have here, and that is actually those points. So now we can see the sketch of our graph, and that is our parabola. So again, this was graphing a quadratic function by simply plotting ordered pair solutions. In other words, plugging in values for x, see what you get out for y, and plot enough points to where you can see the sketch of your graph. As soon as you see that it makes that turn from that parabola, you can automatically predict what the other points will be. And there you have it, graphing a quadratic function. Next, we want to cover graphing a quadratic function by completing the square. Okay, so we're going to solve this one a different method. We're going to use completing the square, or what we would consider some form of completing the square process involved in solving it. So in addition to that, we're going to, after we graph it, we're going to identify certain characteristics such as the domain, range, vertex, axis of symmetry, and the intervals of increase and decrease. So let's start first by getting the problem set up to start the completing the square process. So recall that you want to get your x terms there by themselves. Now we're not going to move that 5 over to the other side because we don't want to create two different sides of an equation. It's a function, so we want to keep it in a function form. So what we're going to do is just move it to the back. It still is on the same side as the other terms. Okay, so here's what I mean by that. In essence, what we're doing is we're going to rewrite the equation from the regular standard or general form to vertex form. So to do that, again, you're going to isolate your or group your x terms together. And again, we did not move 5 to an opposite side or anything. We just kind of pushed it toward the back. Now let's focus on completing the square. Recall, you look at the middle term and you say, what's half of 6? Half of 6 is 3. Now square that number. 3 squared is 9. So that means my missing number to complete that square would be positive 9 there. Now, if I add 9 to that, I need to also subtract 9 from that. And that way you really didn't change the equation or alter it at all, because if you add 9 to something and you take the 9 away, it's again as if you hadn't done anything to it. So notice we put the subtraction there on this side over where the 5 was, and we're almost done. All we got to do now is to factor this perfect square trinomial, and we know this is going to factor into x plus 3 squared. And then when we combine a positive 5 with a negative 9, we're going to get negative 4. And there you have it. We have it in vertex form. So we could also just use transformation at this point to know that this is nothing more than just the parent function, the quadratic function that has been shifted to the left 3 units and then shifted down 4 units. So once we get that graph there, it will look in that manner, okay, which shifted again 3 units to the left and then 4 units down. Our vertex, if you were able to tell that, you could see that your x value was negative 3 and your y value was negative 4. In terms of what are the characteristics we need to look for, and that's what's the domain, as well as the axis of symmetry and the intervals in increase and decrease. But before we do that, let's go ahead and find the x and y intercepts, get some other points just for safety. So Recall, to find the x-intercept, you have to let y be 0. And to find the y-intercept, you have to let x be 0. In other words, you have to let one variable be 0 in order to find the other. So let's go ahead and start with the x-intercept, letting y be 0. So we're going to solve this using the square root property, which is to add 4 to each side, take the square root of both sides, and that's going to leave you with x plus 3 on the left side and plus or minus 2 on the right side. Last step to solving that is to subtract 3 from each side, and you're going to have negative 3 plus 2 and then negative 3 minus 2. So those two values, as you can see, once we combine those numbers, is going to be negative 5 and negative 1. So that's my x-intercept. Now let's go ahead and find the y-intercept. To find the y-intercept, we're going to do the opposite. We're going to let x be 0 and then solve for y. When we do the math there, we're going to have 3 squared. 3 squared is 9, and then 9 take away 4 is 5. So when you plug in a 0 for x, what you get out for y is a 5. So the ordered pair 0, 5 is our y-intercept. So I think we have enough points to where we should be able to see the sketch of our graph. So on the next page, let's go ahead and begin sketching our graph. So here's our graph. And sure enough, if you see here that our graph was shifted to the left 3 units and down 4 units. Also, we identify, remember, our vertex was at negative 3, negative 4. What is our axis of symmetry? If you said x equals negative 3, that is correct. That is the vertical line that is passing through the center of our vertex there. We also identified the x and y intercepts as well. Recall that we found them algebraically, and it was negative 5 and negative 1, and sure enough, if you can look at the graph, that's exactly where it touches the y-intercept. We found that as well algebraically, recall that, and it is exactly what you see there. So we have those points. Lastly, we want to find what are the intervals in which this graph is increasing. In other words, moving from left to right in an upward motion. And we can see that that starts at negative 3, and it will go all the way to positive infinity. And so therefore, the way you write it, you would write it as negative 3 to positive infinity. How about the intervals in which it's decreasing? And if you said from negative infinity to negative 3, then you are correct. Because notice that it is moving from left to right there in that downward motion. That's where it makes its descent. And there you have it. I think we found everything there. Graphing a quadratic function using the completing the square method. The last method we're going to introduce with graphing quadratic functions is using the vertex formula. So you can use the vertex formula, especially if you have the equation in the general or standard form. Recall that when it's in this form, the coefficient of the first term, we call that A, the coefficient of the second term, we call that B, and the coefficient of the constant, we call that C. So in this case, we can see that A is 2, B is negative 4, and C is 5. We can also tell from our coefficient of the first term that because it's positive there, this is going to be a parabola that is going to open upward. Now the vertex formula itself, to remember that it is always going to be, to get your x value, you're going to calculate negative b over 2a, And then once you get that value, you're going to go and take and plug that back into the function itself in x's place. In other words, you're going to evaluate it for that function. And that is why you see f of negative b over 2a, because whatever you get, whatever value that is you get, you then have to evaluate it for that value, and that gives you your y value of your vertex. Okay? So let's go ahead and plug those values in. Let's start with our x value. So that's minus b over 2a. So that's minus b is negative 4. So that'll be minus negative 4. And then on the bottom, it'll be 2 times. If a is 2, that'll be 2 times 2. Negative 4, but with a negative in front of it, becomes plus 4. So we have 4 on top, we have 4 on bottom. 4 divided by 4 is 1. So our x value of our vertex then is 1. Well, how do we find our y value of our vertex? Well, all you have to do is take that 1 and plug it back into the equation itself. In other words, you're going to find f of 1. Evaluate it for 1. Once we do that, it's going to look like so. Let's go ahead and do the math. 1 squared is 1. 1 times 2 is 2. So 2 is going to be my first number. My middle number is going to be negative 4. And the last number is 5. Now let's combine those three numbers together, moving from left to right. A 2 combined with a negative 4 is going to give me negative 2. Negative 2 combined with a positive 5 is going to give me 3. So our output, or our y value, is 3. So my vertex is located at 1, 3. And now that we know our vertex, recall that the axis of symmetry is going to go through our vertex. So that vertical line there is going to be x equals 1. In terms of our x-intercept, to find our x-intercept, we have to let y be 0 of our function. Now, this particular function here is not factorable, so since it's not factorable, I'm going to utilize the quadratic formula to find the value of x. So when we plug that in, what we noticed is we have a negative underneath the radical, which means that this produced an imaginary solution. There was no real solutions, which means that we're not going to have an x-intercept. And that's right in line with this graph, because if you see here that this particular function, the coefficient of the first term is a positive, which means our parabola is going to be facing upward. So if this is our vertex here, the point that you see on the screen, and our parabola facing upward, that means it is nowhere near the x-axis. And whenever your graph of a parabola does not touch the x-axis, then there are no real solutions, only imaginary solutions. So therefore, you would just simply state that there is none, no x-intercept, because it does not touch the x-axis. Let's find a y-intercept, because I do believe we have a y-intercept. So recall, to find the y-intercept, you have to let x be 0. So into the original equation here, we're going to remove the x's and replace them with zeros. When we do that, we see that we can clearly see that our output is 5. So our ordered pair then is 0, 5. So our y-intercept is located there at 0 and up 5. We actually have enough points to see the sketch of this graph, because recall, at the axis of symmetry, that point where that line of symmetry, if we have the y-intercept as 1 unit over to the left from our line of symmetry, all we have to do is move 1 unit to the right of that line, because there's a point there as well. And there you can already see the sketch of your graph. Lastly, let's find the intervals of increase and decrease. So where on this graph is it increasing? In other words, moving from left to right in an upward motion. If you said from 1 to positive infinity, then you're absolutely correct. That is the interval in which it is increasing. And how about decreasing? Yes, from negative infinity to 1. And there you have it. Graphing a quadratic function using the vertex formula. And now it's your turn. Which of the following is true for the graph of the function f of x equals negative 2x squared plus 4x plus 1? I want you to use the vertex formula. Pause the video and see if you can identify where the vertex is and whether this parabola will open upward or downward. Okay, so how'd you do? All right, so if you did it correct, the correct answer should be B. Okay, now in case you want to know why it's B, well, let's go over it and see how you did there. So if we look at our equation that we're given, we can see that A is negative 2 and B is 4. We don't even need to know what C is because C is not even part of the vertex formula. So to get your x value, you have to go negative b over 2a. So that's negative b is 4 over 2 times a. A is negative 2. So what you wind up with is negative 4 over negative 4. Negative divided by negative equals a positive. So our x value is 1. How do we find our y? That's correct. You have to evaluate it for that value. So we have to find f of 1 enter our function. So if we take our function itself, remove all the x's and replace them with 1 and do the math. One squared is 1. 1 times negative 2 is negative 2. So we're going to have negative 2. The middle term is going to be a 4. The last term is a 1. Now moving from left to right, combining a negative 2 with a positive 4 is going to give you a 2. 2 plus 1 gives us 3. So our y value is 3. And that is why it is choice B with a vertex at 1, 3. And the fact that the coefficient of our squared term, and in fact, let me use a different color here. Because it's a negative, this is a parabola that is going to open downward. And that is choice B. Okay, good job. Okay, that's it for this video. Thank you for watching MVP tutorials created by your instructor, Dr. Speights. Please feel free to like, share, and subscribe. Goodbye for now. I hope you'll join me in the next video.